Okay, what is the theoretical Van't-Hoff factor I for calcium chloride? Okay, so first we have to write the equation. So we know that we have calcium and we have chlorate. And chlorate is a polyatomic oxoanion, which we can get that from the rule of 7. So let's see. So using the rule of 7, we know that Cl is going to have 3 oxygens and a -1 charge. So from the workbook, this is the rule of 7 with BCN, PS, AS, SE, CL, BR, I, and AT. And these group of 3 up here, they're going to have a -3 charge, -2 charge, -1, and they're all going to have 3 oxygens. And this cluster of 4 right here, these two have a -3 charge, these two have a -3 charge, these two have a -2 charge, but they're all going to have 4 oxygens. And then for this cluster of 4 right here, they're all going to have a -1 charge, and they're all going to have 3 oxygens. So since chlorine is in this group of 4 right here, it's going to have a -1 charge and 3 oxygens. So ClO3 with a -1 charge. And then from the periodic table, we also know that calcium has a +2 charge because it's in the second row. So +2. Okay. So from that, and then from looking at the charges, we can know that to balance it out and to make it equal 0, we're going to need 2 of these. 2 chlorates. So our equation, balanced equation, is going to be Ca, switching the crosses, crossing the charges, and we're just going to have one of those, and then ClO3, but we need 2 of those because it only has a -1 charge, and it needs to match the +2 charge, so we need to have 2 of those. And whenever we're counting the Van't-Hoff factor, polyatomic oxoanions will count as 1. And so in order to see how much we have of each, we're going to have 1 calcium, but then we have 2 chlorates technically. So 2, and then add those together, and Van't-Hoff factor is 3. And if you wanted to see that in a picture, it's basically going to look like we're going to have a Ca plus ion. It's going to be a cation since it's positive charge. And then we're going to have a ClO3 -1 anion negative charge. And then we're going to have another ClO3 -1 anion. And that also gets you 3.